Recording in progress.
Good evening, everybody. We'll start the class. Today, yes, good evening, ma. Today, as I said in the last class, we'll be discussing about skew lines today. Skew lines. First, we'll be discussing what are skew lines. Then, how to find the distance between the given two skew lines, and also what is the equation, how to find the equation of the shortest distance between the skew lines. Okay. Three things we are going to discuss today. And of course, as we discussed many things in the coplanar lines, yes or no, we discussed in the previous classes coplanar lines, right. So, it is the extension of that concept. Okay. So, what is that coplanar lines we discussed there, and how it is going to different, the skew lines, how it is going to be different from the coplanar lines, that we are going to discuss. So, today we will be discussing about, see in your syllabus they have given, in analytical geometry syllabus, what is the topic they have given? The shortest distance between the two given skew lines, yes or no, that is the topic we are going to discuss today. Shortest distance between two given skew lines. Shortest distance between two given skew lines. So, here itself, first we will be discussing what are skew lines. Then we will be discussing what is the shortest distance between these two given skew lines, and then what is the equation of the skew lines. What is the equation of the skew lines? I mean, we are going to find not skew lines equation they will give. We will be finding what is the equation for the shortest distance. Okay. Shortest distance we are going to represent by a line. What is that line equation? How to find it? That is what we are going to discuss three. Okay. So, three things. One is skew lines, we will be discussing what it is. Then we will be discussing what is the shortest distance. What is the shortest distance? And then we will be discussing the equation of the line of shortest distance. Equation of the line of shortest distance. Here ST I write. ST stands for shortest distance. So, three things we will be discussing today. Okay. And here last class we have discussed what are coplanar lines. What are coplanar lines? When two lines intersect, we can make a plane to pass through the two lines. Then it is going to become what? Coplanar lines, or in other words, two lines, if it is lying on a plane, they are called what? Coplanar lines. Yes or no? So, two lines when they are intersecting, yes or no, we can allow a plane to pass through these two lines. Then these two lines are going to be what? Coplanar lines. Okay. I gave example. This is one line, this is another line. When they intersect, what can we do? We can allow a plane to pass through these lines, right. So, it is going to become what? Coplanar lines. Even the parallel lines, if the lines are parallel, I said what? Though it is going to lie on the plane, it may not intersect. We say that they are intersecting at infinity. Yes or no? These things we discussed in the coplanar lines. So, what is that we discussed there? How to find the point of intersection if the lines are coplanar lines. Okay, we have devised the condition to say the lines are coplanar lines. Yes or no? The two given lines are in symmetric form. Yes or no? So, symmetric form. One line is in symmetric form, another line is in what? General form. Another line is in general form, and two lines are what? In general form. In all the three cases, we devised what condition, yes or no, to say that given two lines are coplanar lines. So, we know what is the symmetric form of given lines, yes or no, and the symmetric form and general form, you know, in all the cases, how can you say that given two lines are coplanar lines, that we discussed. And then we discussed about how to find the point of, if they are coplanar. Coplanar means they are going to intersect, that is the case we are discussing here. So, when they are intersecting means how to find the point of intersection, yes or no, that also we discussed, how to find the point of intersection, that we discussed in each case. And what, and we have devised a method, or we have studied a method to find what, the plane in which both the lines are lying, yes or no, the plane containing both these lines, how to find the equation of the plane, that also we discussed. That is with respect to coplanar lines. Now, we are going to restrict ourselves to only the skew lines, right. Here the lines are intersecting means what I am saying, they are coplanar lines. Now, if the lines are not intersecting and if they lie on two different planes, then those lines are called what? Skew lines. Okay. Just diagrammatically, if I want to say this one diagrammatically, I just will take two planes. Okay. So, two planes, for example, this is one plane, this is another plane, this is another plane, two planes we have. Okay. And now let us consider some line like this, and here some line like this. These are the two lines. See here, this is in one plane. See, this is one plane and this is another plane like this. Okay. One line I am taking from the upper plane, the other line I am taking from the lower plane, right. And see the two lines are what? Not parallel, yes or no. They are not going to intersect, first of all. They are not going to intersect because they are in two different planes. They are not going to intersect. Okay. And these two planes are parallel, first of all, yes or no. Two planes are parallel. Suppose if the plane is tilted like this, then what will happen? Definitely lines will intersect. You understand? Suppose if I take some other plane like this, some plane. Okay. So, what will happen if I take some line like this? If I take some line like this and if I take some line like this, what will happen? So, in plane they will not intersect, but the property of line is what? It might extend. Here this might extend, it will intersect. They will become what? Intersecting lines. If they are intersecting line, they are not going to form skew lines. Yes or no? So, only thing is what? The lines which are not intersecting and they need to, skew lines mean not intersecting lines, and they are going to lie in two different planes, not in a single plane. Okay. And this is what it is. So, we will take these two lines like this as I have taken earlier. This is one line, this is another line. Of course, they are not parallel lines and they are not going to intersect. Okay. So, your skew lines never intersect, they are not parallel. Okay. Neither intersect nor parallel. Those lines are what? Skew lines. These two lines are what? Skew lines. These two lines are skew lines. Yes or no? You have to imagine line like this. One is in one plane, another line is in another plane. So, it is not going to intersect. Okay. Yes. Now, if you take a line, so see, if I take the another line like this is going to be parallel to this line. Yes or no? Then these two lines are not skew lines. Then these two lines are not skew lines. They should not be parallel and they should not intersect. Okay. Though they are lying in what? Two different planes, they should not be parallel. Right. I hope you have understood what is skew lines. First you will write what is skew line. Okay. skew lines, just take down. Skew lines. Two lines are called skew lines or not intersecting lines. Two lines are called skew lines or non-intersecting lines. If they lie on two different planes, if they lie on two different planes, lying on two different plane is alone not enough. What it should satisfy? They should neither intersect nor parallel. Okay. So, skew lines neither intersect nor parallel. Neither intersect nor parallel, that is it. This is the meaning of skew lines. Okay. Whereas in the case of coplanar lines, they will intersect. They can be parallel also. Yes or no? Coplanar lines, they may intersect, they can be parallel also. Opposite. Here it is not going to intersect, it is not going to be parallel. This is what skew line. What is the difference between? That is the difference between coplanar lines and skew lines. Okay. Now we have to find the shortest distance between these two skew lines only. So, as we have taken, let me take the same line and we will erase this line. These are the two skew lines, yes or no? This is in plane 1, this is another plane, this is line 1, this is line 2. Okay. Now, I want to find the shortest distance between these two lines. Okay. There are two methods to find the shortest distance, that is what we are going to discuss. Okay. So, the shortest distance between these two lines is going to be what? If this is the plane, this is the plane, line is lying on both the planes, the shortest distance is going to be what? The perpendicular line joining both the lines, yes or no? Here we have one line, here there is another line, am I right? So, the shortest distance is going to be what? The perpendicular line joining both the lines. Okay. So, the shortest distance I will take, this is the, I will take perpendicular line joining these two lines. This is going to give what? Shortest distance. So, this is P, I will take, this is the point Q. If I join this, I will get what? A line. Okay. And the distance between these 2 points, that is the perpendicular. This line is perpendicular to both the lines. Okay. For first line and the second line, the line PQ is perpendicular. This is going to be what? Shortest, this is going to give the shortest distance between two skew lines. Okay. And to find this shortest distance, we have two methods. One method, in first method, we will be using the concept of projection. Already I have taught you what is the projection. So, we can use the projection method to find the distance, shortest distance, or we can use the coordinates method, just points. No, if I know the points, I can find easily what is the shortest distance, that I can use using the coordinates, finding what is point P, what is point Q by 2-point distance formula. Using that, we can find what? Shortest distance. Or other method is projection method. I will be teaching both. So, whichever you are comfortable with, you can take that and you can solve the problem. Okay. In my opinion, the coordinates method, that will be easy, I guess. Okay. And we can use the projection method also, it is your wish. Okay. So, now we have how to find the shortest distance. So, shortest distance between these two skew line is what? The line which is going to be perpendicular line, the distance of that perpendicular line joining the two skew lines. Yes or no? Next, we will be writing what is the shortest distance between skew lines. Shortest distance. The shortest distance between two skew lines, is the length of a perpendicular line, perpendicular line joining two given skew lines. Yes or no? So, the shortest distance between the two skew line is the length of the perpendicular line, joining what? These two lines. Yes or no? A line which is going to be what? Perpendicular to both the lines, and this line is going to meet these given lines at some point. Now, we can find what is the length, that is going to be what? The shortest distance between given two skew lines. That is what the meaning of shortest distance between two skew lines. Now, we have understood what is skew lines. Yes or no? What are skew lines? How to find the shortest distance? How to find the shortest distance? What is that we are going to use? I did not say now. So, what is the meaning of shortest distance? I have said. Next, we will be discussing about the methods to find the shortest distance, and also what? Methods to find the equation of this line. Shortest distance line is there, right? A perpendicular line. For that, what is the equation? How to find the equation? That also we will be discussing. Okay. Okay. Now, when I see this, I am going to next discuss about the equation. The equation we will be using the same concept, intersection of two planes. One plane is what? Passing through this line, containing this line of shortest distance, one plane. The another plane is going to have what? Another plane passing through this line, having this line of shortest distance. You understand? One plane, it is going to go like this. Another plane, it is going to come from here. Are you understanding what I am saying? So, imagine that the line is here. Okay. So, we are going to allow one plane through the line, and this plane is what? Passing through the line of shortest distance also. Here we have the line. Another line somewhere here on the upper plane. Yes or no? So, if it is something like this, means we are going to allow a plane to pass through the line and also through what? Line of shortest distance. You understand what I am saying? So, this plane is going to pass through one line and the line of shortest distance. Another plane is going to what? Pass through another line and the line of shortest distance. Now, when they are going to meet, they are going to meet at what? This line only. They are going to create this line. You understand? We are going to allow one plane like this. We are going to allow another plane like this. They are going to meet at this point. I mean this line. They are going to meet at this line. You know, already we discussed the plane concept. When two lines are intersecting, it is going to create a line. Okay. So, we can find easily what is the line. How do you find line? Just you find what is this plane equation, what is the another plane equation. Yes or no? Both the planes, if both the planes equation you are finding and writing together, it is going to indicate a single line. That line is nothing but this line. You understood? Those things we have discussed. Whatever we discussed, we are going to recall and we are going to solve the problems. Okay. First we will write the general method. Year 2 we have 3 categories. They are going to give 2 lines, right, skew lines. If the 2 given lines are in symmetric form, how to find the shortest distance, how to find the equation of the shortest distance. Okay. One line is in symmetric form, another line is in general form. Both the lines are in general form. All the 3 category we are going to discuss, but in this class we will be discussing what? Only one concept. If the given 2 lines are in symmetrical form, how to find the shortest distance, how to find the equation of the line of shortest distance. That is it. Okay. So, we will restrict ourselves to only what? Symmetrical form. If the given 2 skew lines are symmetrical form, how to find the shortest distance. Okay. Next. Let it be as it is. Okay. Next we are going to study about how to find the length, of the shortest distance, and how to find the equation of the line of shortest distance. Okay. So, 2 concepts we will be discussing: shortest distance between 2 given skew lines, the shortest distance between 2 skew lines, how to find the shortest distance between 2 skew lines, and equation of the line of shortest distance. So, these 2 things, how to find the shortest distance between the given 2 lines. Just now I said what is the shortest distance, how to find, and methods we are going to discuss, different methods we have, that we are going to discuss, and also how to find the equation of the line of shortest distance. Okay. 2 things. In that, first ourselves restrict to what? Given 2 skew lines are in symmetrical form. Okay. Given 2 lines are in symmetrical form, how to find the shortest distance, and equation of the line of shortest distance. So, both skew lines are in symmetrical form. Both the skew lines are in symmetrical form means how to find the shortest distance between the skew lines and what is the equation of the line of shortest distance we are going to discuss, right. So, this is what we are going to discuss. In this we have 2 methods again. We are going to restrict ourselves to what? Only symmetrical form of a straight line. Okay. In this again we have 2 methods. First method is what? Projection method. Either you can use projection method or general coordinates method. It is your wish. First we will be discussing about projection method, how to find the shortest distance between the skew lines by using the projection method. Before going to the projection method, I like to recall this concept. The concept is what? Suppose you are having a baseline and you are having another line. If you want to project this line on this line, where we know the direction cosines of this line are L, M, N. L, M, N are the direction cosines of this line, and this line passes through 2 points. One is A whose coordinates are x1, y1, z1. Here another point B whose coordinates are x2, y2, z2. Yes or no? Now, if I project this line on another line whose direction cosines we know, what is the projection? Projection. This is the projection. Yes or no? So, projection of the line or length of the projection, it is going to be given what? The formula yesterday only I recalled you. What is it? L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. It is going to give what? Length of the projection of this line on this line. Yes or no? Here you should know what? Coordinates of 2 points. Here you should know what? Direction cosines where you are projecting. If you know the direction cosines where you are projecting, right, the line and its direction cosines, and if you know the two coordinates of the line which you are projecting, you can find what? The length of the projection using this formula. Yes or no? Okay. So, this one we know it. We are going to use the same concept here. Now, look at here. We want two lines here. Yes or no? Where we are projecting and what is being projected, right? So that we can find what is the length of the projection. Okay. So, having understood this, now we are going to say. See here, before writing anything, I will just explain what it is. See here, this is the line I draw like this, the line. This line I draw like this. Suppose let us take this is the shortest distance PQ. This is the shortest distance. We will take that the line is passing through the points A and B. A and B, and whose coordinates we are going to take x1, y1, z1. Here the coordinates are going to be what? x2, y2, z2. These are the coordinates of the point B. These are the coordinates of the point A, and this line is passing through the point A. This line is passing through the point B. Yes or no? If I join them, I will get to what? A line. I want to find this length only, no? What we can do? We can project this line AB on PQ. We can project line AB on PQ if direction cosines of PQ are LMN. Direction cosines of PQ are LMN, and we know what? AB, and we are going to project on PQ. Now we can write the length of the PQ. Yes or no? Length of the PQ, that is what? The shortest distance between the two skew lines. What is it? Length of PQ, it is going to be what? Yes, or projection of AB on PQ. Projection of AB on PQ, it is going to give what? Length of PQ only. So, length of PQ, it is going to given by what? Again same formula, no changes. Yes or no? L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. By using this formula, you can find what? The length of the length of the shortest distance between the two skew lines. Shortest distance we can find between these two skew lines by using what? Projection method. This is one method. You understand? This concept we have discussed already. Just we are going to apply it and we are going to get the answer. Now we will write it properly. You understand? See here, when I join them, it is going to give what? This is the shortest distance we want to find. So it is a line, straight line. This is the shortest distance, and this is what? These are also what? Point on two different lines only. A here, B here. A coordinate x1, y1, z1. B coordinate x2, y2, z2. Understood? Okay, fine. Now we will write this. That is it. So in the projection method, and two given lines of symmetrical form we have said already. Let us take that two given lines. Let, what is the one line we are going to take? X minus x1 by L1. This is equal to y minus y1 by m1. This is equal to z minus z1 by n1. Let us take this is equal to say r1. Here itself we will take. Okay. This is the first line equation, skew line equation. So this line equation I am taking like this. The another line, let this one and another one x minus x2 by L2, this is equal to y minus y2 by M2, this is equal to z minus z2 by N2, this is equal to R2. So, again we are taking like this, this is going to be what? Second line. Okay, this line equation it is. Two lines we have taken in symmetrical form. Afterwards what? We have to find the direction ratio here, direction cosines we may not know, we are going to assume it is going to be LMN. Okay. From here we will be finding what is that LMN. Understand? Okay. See here, the first line passes through the point x1, y1, z1 having the direction cosines L1, M1, N1. Second line passing through the point x2, y2, z2 having what? Direction cosines L2, M2, N2. Yes or no? First line x1, y1, z1, the point through which it passes through. Second line passes through the point x2, y2, z2, that coordinate. Yes or no? Okay. Now, let us assume that L, M, N be the direction cosines of the shortest distance. We do not know, right? PQ. So, we will assume let L, M, N be the direction cosines of the line of shortest distance, between, let this one and this one you write here be given two skew lines. These are these two given skew lines that you have to write it, and then L1, M1 be the direction cosines of the line of shortest distance between what? 1 and 2. Yes or no? 1 and 2 are skew lines between 1 and 2. Okay. We have taken LMN or the direction cosines. Then, if that line shall I take that line to be P and Q? Let PQ be the shortest distance, line of shortest distance, where P is a point on the line 1, Q is some point on the line 2. Yes or no? Let PQ be the line of shortest distance between 1 and 2, both meaning same. Here I did not say what is that line. If you want, you can write this first. Let PQ be the line of shortest distance between the skew lines 1 and 2, and the direction cosines of this PQ only, what is that we have taken? LMN. Yes or no? Direction cosines of this PQ only we have taken LMN. See here, when this is the line of shortest distance mean, then this line is what? Going to be perpendicular to both the lines, both the skew lines. So, PQ is going to be perpendicular to what? Both these skew lines 1 and 2. Okay. Therefore, PQ will be perpendicular to the lines 1 and 2. Since PQ is the line of shortest distance between the two skew lines, the PQ is going to be perpendicular to line 1 and line 2, they are the skew lines. Okay. Now, why I am bringing this perpendicular concept? We know if two lines are perpendicular, we can what? Associate their direction cosines, lines, not for planes only normal. Here all are lines. Yes or no? We can relate their direction cosines and we can form two equations. Yes or no? This line and this line are perpendicular. I have taken for this line direction cosine as what? LMN. For the first line, what is the direction cosine? L1, M1, N1. So, L1, M, M1, n1 is going to be, if you add it, it is going to be equal to 0. Yes or no? So, using this perpendicular concept, I can form what? Two equations, right? Shall I write the two equation by erasing here? Shall I erase all these things? Yeah. Have you written this? Yes. Okay. Are you all understanding what I am saying? Yes? Jayasti, Divyasti, Prabhu? Okay, fine. Now, so since they said, I have said perpendicular, which line? The line PQ is perpendicular to given two lines, right? Therefore, we have what? We have two equation. One is what? L1 plus M1 plus N1, this is equal to 0. Okay. How it is coming? We have discussed already. Okay. So, then another one. For second line also, this line is perpendicular. To say that, we are going to have another condition, L2 plus M2 plus N2, this is equal to 0, right. So, by solving the above two equations, we get what? The proportional values for LMN. The proportional values for LMN we will get, or we can exactly also find LMN. Yes or no? So, by solving